like to take the opportunity again on behalf of ICAO to thank Bombardier for their sponsorship of the coffee break. And as was explained and is in the program in relation to this session, we're now going to get more operationally focused, and we're very fortunate to have some leading experts in their field within their respective organizations who are actively out there involved in research, testing, operations, evaluations to actually see how we progress and make UTM and new airspace operations a reality. Just a few reminders before we go into the session. The presentations from all of the sessions at the event this week will be posted on the ICAO GANIS-SANIS website, but that will not actually occur until the end of the symposium. We didn't have the opportunity on the last session to see Florian's presentation. So that is going to be posted on the actual website, and I'll ensure at some point during proceedings you're reminded that you can actually access the information there, because it's a pretty interesting video to actually watch. So without further ado, I'm going to move into the session. It's as per the first session in relation to, I'm just going to give a brief introduction to each of the panel members. The panel members are then going to do a presentation, and then we're going to move into the Q&A sessions. And again, I will remind you and I'll encourage you to use the email address to get some questions up to me here on the podium later to start asking the panel members. So let's start. And firstly, great pleasure for me to introduce our first speaker, and that's Parimal Kopardekar, Dr. Parimal Kopardekar, affectionately known as PK. And PK serves as NASA's senior technologist for air transportation system, and he develops concepts and technologies to increase efficiency of current operations and enabling future airspace operations. And he serves as a strategic advisor to NASA on airspace research and development, and mentors many research areas and research individuals. PK, welcome to the podium.
Thank you. I'm pleased to be here. I'm here to talk about UTM, UAS, Aircraft Systems Traffic Management, a construct we started about 4 years ago. And I will really be remiss if I don't say that this is truly a collaborative innovation. Even though we may have started or sowed a little seed, it really grown because of you all, and particularly the members that are sitting on the podium here and the previous members who have been actively, directly or indirectly engaged with the UTM, and that collaboration has really been extremely fruitful. I also want to particularly acknowledge and identify my mentor, Steve Bradford, who is the co-lead of the NASA FAA UTM, who actually gave me my first job in 1993, and he regrets it ever since. But so we have been working on this UTM together. So what UTM is really it started off as an ecosystem for supporting drones in uncontrolled airspace. And it really uses FAA's regulatory authority where these services don't exist today. Then we started to go into the details. It starts simple in the beginning, but then you had to go into the details about what services we need, who provides those services, roles, responsibilities, and all kinds of details. But it fundamentally bridges a critical gap associated with lack of support for uncontrolled operations, and these could be uncontrolled airspace and uncontrolled operations in controlled airspace as well, and enables large-scale BV loss, beyond visual line of sight operations. So there are a bunch of principles that basically are very straightforward. These are similar to conventional air traffic management, that you want to make sure that only authenticated operators exist and they are allowed to operate. The drones or UAS stay clear of each other. Drones and manned aviation stay clear of each other. The operator, this is fundamentally important and different than what happens in the manned aviation. The UAS operator has complete awareness of airspace and constraints. Opposite happens in the manned aviation controller or the flow managers. The system, ANSPs have the complete awareness, but the operators don't. Here we are flipping the model. And then the public safety has priority. Those then translate into services, and these authentication, geofencing, track and locate, communication, and spectrum assessment, weather, wind prediction, conflict avoidance, demand capacity imbalance, and some large-scale contingencies. And in this case, the demand capacity imbalance is interesting. In the manned aviation, it's all about volume because of the controller's workload. Here, it's volume, spectrum, visual noise, and factors such as those, other than just the volume. So you have to take into account a number of aspects when you start to look at demand capacity imbalance. So then we went into architecture and roles responsibilities. Previous panel talked about basically defining roles. So we heard from Florian about how the system has to change, how it has to digitize. We heard from Hiroko about how the Japanese efforts are lining up. And we heard from Lance about the fundamental changes in the role responsibilities required. So here what you see is basically a simplified architecture view that shows that we split the responsibilities in three ways. One is the FAA or any ANSP for that matter, who provides constraints and directives such as precedent is in town, you need to clear the airspace, or any other safety related issue. Then we have operator, and then we introduce the third term called USS, US Service Supplier. Now in some cases, the service supplier and operator could be the same. Maybe example, Amazon and Google, who have a fleet of operations, so they may want to provide their own services. But in other cases, they could be different entities. So what that means is that you have to worry about operator-to-operator interaction. And what we do in terms of research together with FAA is define those data exchange protocols, because it is a movement towards the digitization, as Florian mentioned. So defining those data exchange protocols, application protocol interfaces, so that we can share the intent and understand all the pre-existing operations in the airspace and stay clear of them. And then we also have some data providers in terms of terrain, weather, and such. So this architecture fundamentally changes the way the UTM looks things as compared with the current manned aviation. And there is an industry side of it, and there is FAA side of it. So there was a question before, for the previous panel, what is the role of industry? So fundamentally, we leverage industry's ability to provide services, and that allows us to go faster and be more innovative. The next chart, then this is a mammoth task, right? As you can see, this is a big task. How do you go about doing it? So we created 4 chunks, what we call technical capability levels. First one started of just sharing that intent information through UTM kind of research prototype and informing each other of areas of operation through common APIs and such. So and that's where we develop the initial ConOps, the architecture, and roles responsibilities. Then we go to the next level, which is go beyond visual line of sight operations. And the idea there is to show that you can enable BV loss. So you have a plan that you share with everybody, and then you track yourself. Fundamentally, tracking becomes very important as you go beyond visual line of sight, so that you know that you are where you said you are going to be. Then the third capability is heterogeneous operations, where the manned and unmanned could peacefully coexist in the same airspace. So not only are going beyond visual line of sight, but then you're also making sure that interaction with the manned aircraft is safe. And so there is V2V, V2UTM kind of connected systems come into play. So far we have completed TCL 1 and 2. TCL 3 will be completed about March to May timeframe, working with all 6 FAA test sites and the 2 partners that we have that are already sitting on the table here, Google and Amazon. And then capability 4 goes into the urban airspace. And what's interesting about that is you can start to postulate how we actually take advantage of capability 4 and then start to slowly make progress towards the urban air mobility, 1 to 5 passenger electric vertical takeoff and landing vehicles and the operations in the urban airspace. So we are beginning to already migrate towards some of these concepts and variations of this UTM construct towards that. Not only we are looking at low altitude, yesterday you saw high altitude discussion where the UTM also applies, and then we are also going to look at basically capabilities for the, I don't see the timer, am I running out of time? Okay, towards the urban airspace operations. Okay, perfect. Then this quickly shows the different types of schedules. So it's not just creating plans and sharing it, but you can also get different types of alerts in case you're migrating to someone else's airspace, and then you have a contingency you want to notify to other people and such. We have learned some important lessons. One is the weather. If it's too cold, you could have a problem. If it's too hot, you could have a problem, particularly if your the density altitude varies. We did experimentation in Reno, which is about 5,000 feet, and then under hot weather, density altitude was 9,000 feet, and then we have winds on top of that, so the battery could barely keep up to go beyond visual line of sight. Similar things we observed in the cold temperatures with high winds and thermal effects. Weather was interesting, weather causes interesting effects, and then vehicles were bouncing. Some of the vehicles with low wing loading bounced around about 200 feet, which has implications on how close you let them fly without V2V kind of organization. Another interesting finding, this is, you can see those 5 yellow dots are 5 ground control stations, and we had a Piper Cub without radio, no beacon, and then all of a sudden it shows up, even though it was not supposed to. And then aviation is all about unexpected events, as you all know. Expect the unexpected in aviation. So we had, fortunately, radar and other ways to detect it, and then it funneled into UTM, and UTM provided alerts, and then we landed our drones because the priority is to manned aircraft. All right, so this is my last slide and quick recommendation. So basically what we have so far discovered is UTM, when it displays all the information, allows complete awareness for operators. It's really useful. Understanding of weather is really critical. Altitude stratification in case of updrafts and such could be a very could have unintended consequences, particularly when you're doing BV loss. Then altitude reporting has to be standardized, somewhere using MSL, somewhere using AGL with respect to ground control station and such, WGS 84. So we need to standardize that. This is where ICAO plays, and other communities we talked about have very good partnership. And it's all about embracing innovation in aviation while respecting the safety of tradition, as everybody's talked about. And that's what UTM does in a nutshell. I am 2 minutes over my time, or maybe 1 minute, but by all aviation standards, I'm under on-time performance. And
Thank you, PK, and you've certainly been busy over that 4-year period with having a detailed concept of operations, even outlining how service is going to be provided differently. The different test sites you mentioned that are actively involved. So I'm going to come back to you later and ask you how you've managed the different entities that are involved in your work to get consensus moving forward, because I know there's a lot of entities involved. And one of those entities was mentioned earlier, and it's my pleasure now to introduce Mr. Sean Cassidy. And Sean is the Director of Safety and Regulatory Affairs with Amazon Prime Air. In addition to supporting technical and engineering development efforts, he's the leader in Amazon's goal to reach successful regulatory and policy level outcomes in support of the safe deployment of the Prime Air delivery model. Please welcome Sean Cassidy.
Well, thanks very much for the kind introduction, and welcome everybody. This is a very interesting place for me to be, because in my former life I was a military and commercial pilot, and I had the occasion to actually be in this very room talking about safety and technical programs and performance-based standards. And so this kind of tails right on from the slide that PK just left off with, in that we're in an industry which might be using different mechanisms to determine and implement safety standards and the like, but nevertheless, we're still very much inspired by legacy aviation standards and mindsets when it comes to the safety of the airspace system. So one of the things that Steve Kramer said yesterday really got me thinking, and it was a projected growth for the industry. And a pretty prodigious number that he threw out that was expected that the industry would grow, basically it would double on the order of about 15 years. Now, let's put that in context to some of the projections out right now for the projected growth for the unmanned industry. FAA just came out with a report that says that between 2016, we will go from a median number of 42,000 individual units operating in a commercial capacity to 2021, and that number, the median number, is projected to be 420,000 units. That's just commercial operations. The median number for recreational operations in that same time frame is a triple, between 1 and roughly 3 million. If you go to the high side of the projections, you're talking about a growth rate from 42,000 to 1.6 million commercial units. And so it's not just about Amazon. You can see by the slide there, there's all kinds of use cases that are literally coming online every day. And I just came up with a new one. I'm going to have a supply service that delivers neck braces and aspirins to the 4 folks that are sitting in the front room looking up like this at the screen. So, but just to give you an idea, and this is an industry that is accelerating, if anything. So I empathize with the policymakers. We empathize with the regulators because you're looking at this exponential growth rate, and you're trying to figure out how do we get our arms around this? How do we maintain the safety? And a term that was thrown out a lot, how do you define those interfaces between legacy ATC and emerging, air traffic operations involving, primarily small UASs operating at low altitudes? Well, the way that we tend to think about it is, let's start with the materials in the room. Everybody's got one of those in their pocket right now. It's a cellular-enabled, internet-connected device. There are already scalable solutions that have been demonstrated in the financial industry, in the telecommunications industry, and the like, which provide for safe, scalable operations using established technology. They're also adaptive and scalable across a broad range of regions. I was just here for the Drone Enable conference a few months ago, and one of the imperatives for ID and tracking is the ability to deploy worldwide. Think about looking at emerging countries. How many of those countries have landline operations versus how many are Wi-Fi, broadband, and wireless enabled? I think we all know the answer to that. So talking about interfaces, the first thing we need to think about is how do we translate the way we think about layered safety from a traditional aviation mindset to an emerging UAS mindset. So when we file a flight plan, we file it with an ATC authority. They compare the flight plans and they deconflict them, and then they say, okay, you can go fly. In an unmanned traffic environment, we think about that in terms of comparing trajectories online, basically almost like an email exchange that compares your geospatial coordinates and says, okay, how do we deconflict for 3D plus time-based separation, a little bit more strategic. When we think tactical, the analog for tactical operations applied to ATC would be collision avoidance systems, where you have airplanes perform interrogatives on each other. We think in terms of UTM and UAS systems in terms of things like Wi-Fi and dedicated short-range communications, because these vehicles, for the most part, are traveling hotspots. They come within proximity of each other, and they're able to deconflict. And then, of course, the choice of last resort, but most important, is the ability of the pilot, or in our case, onboard sensors, to detect something close in and make sure they provide that third layer of safety. So when you think about it from an air service provider, an ANSP provider, their authority must remain throughout the system, regardless if it's a manned or an unmanned system. But the way that we think about managing operations is an exception model rather than a hands-on management model. Think about those numbers that I threw out there. If you had to play a role of hands-on controller to all those operations, how effective do you think that would be? And I think we know the answer to that. But the solution is through automation. It's through vehicle, hardware, software-defined systems that perform at a very high level of fidelity, at a very high level of reliability, and something that is scalable through these technologies that we talked before about. So let's build a system. So say we have Amazon drones and they're talking to our controllers or our infrastructure. Maybe we have a Google fleet of drones or somebody else that's talking to their own infrastructure. Now we're going to start talking about interfaces. The first thing we need to do to maintain safety and separation assurance is through communicating through an interoperable standard, something that's harmonized and something that is easily understood by everybody who's controlling an individual drone or a fleet of drones. And again, there's the role of the ANSP. We need to ensure that the role of those oversight entities remains unabrogated. In fact, they have the ability to direct the movement of traffic, both manned and unmanned, in emergency situations, TFRs, natural disasters, and the like. Speaking of service suppliers that PK just talked about before, there's certainly a role for those entities that are not necessarily operating vehicles, but are providing vital services, traffic information, weather, perhaps something that's related to a specific business operation, agricultural, and the like. And you know what this looks an awful lot like? Is an architecture that already lives today, materials in the room. It's an internet-based protocol, cellular industry, or others. All they're doing is exchanging digital packets of information between each other. The challenge is to make sure that it's standardized and interoperable. So our kind of term of art for this is unmanned automated controllers, or UACs. And again, we think about it in terms of a reliable internet-based service. It's something that can be affordably built and scaled up. Think about this. It can't just be a US and Canada and France and Germany solution. It has to be a worldwide solution, and it has to be technology agnostic. It cannot be anonymous, and that's one of the things that we touched on with the previous Drone Enable event. We have to ensure that there's a means for remote identification and tracking of all these vehicles to preserve safety, security, and privacy concerns. So what's the role of automation? Well, let me back up a little bit. What's the role of people? The role of people is to define policies, to define things like separation standards, to define what types of spectrum we can use and the like. And then it's the role of the industry to build to those standards and to adhere to those policies and then enforce, adherence to those, of course, with the oversight of the auditor, in this case, the regulators. So what's our shared path forward? It's a walk, crawl, run thing. One of the things that I was very mindful of when I was on the NextGen committee is that NextGen is not a system in which you flip a switch and suddenly you have NextGen being applied. It's something that's a gradient that you grow into. We need to start with shorter-term guidelines, things that we can do right now to demonstrate safe deployment, build off of those, and then build into performance and safety standards. We need to then implement technical standards that ensure that level of interoperability. Just think about GSM and CDM phones. I mean, they have different technical standards, but they're fully interoperable, right? And then finally, we need to be technology agnostic. We have to set the performance standard, we have to set the performance bar, and then we need to be embracive of future technologies. So that's all I have. Thank you so much for your attention, and I look forward to your questions.
Thank you, Sean. Very interesting, especially considering your view there on how the control of traffic will change, and I'm sure you'll get some questions from the audience, and if not, I got a few questions for you. So moving on to our next presentation, it's my pleasure to introduce Mr. Frank Mattis, who has 18 years of experience in establishing strategy and business development, and he's currently working for Thales. His main focus is advanced air traffic management concepts and solutions in the United States and the global market. So his actual position in Thales is Director of Strategy and Business Development, leading work in the US and leading the digital transformation efforts for Thales USA, which encompasses UAS traffic management, UTM, and air traffic flow management. Please welcome Frank Mattis to the lectern.
Can help design air traffic management systems, but I can't figure out this thing, so it's great. Thanks very much for that. The panels this morning have been enlightening. It's an honor to be part of this industry and an honor to be up here on the stage with these distinguished gentlemen from an industry perspective, and just seeing how we're growing in air traffic and the direction that the industry is headed in general. Just to give you a little bit of background about Thales, who we are, what we do. We are a global organization. We have about 65,000 people. We have many different divisions, and these divisions are important to us as we look at how technology will continue to evolve for UAS traffic management. So from space, defense, aerospace, security, transportation, all of these industries are impacted by unmanned systems in some way, shape, or form. So we have a lot of discussions around what UTM means, and each one of us has some varying level of understanding of what UTM is, and we all have different definitions. So from a Thales air traffic management perspective, we sort of break this down into low-level airspace management instead of calling the term UTM. UTM to us is a system of systems, multiple pieces that need to come together, similar to an air traffic system, from surveillance to command and control systems to fleet management to airspace management. All these things have to come together in a very secure manner, and we need to plan for the future. So just as Sean was saying, I think we need to look at technology agnostic solutions, ones that are scalable and ones that will help us move on into this next generation air traffic management system to accommodate low-level altitude integration. So today, UAS operations, we hear a lot of different views globally from our customers about how to integrate small UASs into the airspace. We say it's small UASs, but it's also general aviation, it's remotely piloted vehicles, it's personal air vehicles, there's helicopter traffic, everything at low altitude airspace. So we look at this, as I said, a system of systems. So there's rules to the road today that we must accommodate, and just because we can build something that flies doesn't necessarily mean that we can. We also need to look at how do we advance the air traffic system today to accommodate new technologies, new functions, new applications, and do it in a safe manner that does not create a safety situation, an unsafe situation for manned and unmanned systems alike. There are areas that are low density, low risk operations that we can do today. A lot of the unmanned integration work that we're doing is in rural areas and areas with little populations to no population. There's limited regulation, limited enforcement, and what we're trying to do is gather a whole bunch of data to prove to the regulator that we can continue to move forward and provide a path towards a safety risk management assessment to then move beyond these operations. In higher density environments, higher risk operations will occur. We have to find structured access to the airspace system. We have to mandate rules. We need to have vehicle standards. Centralized control is important, and enforcement of the rules of the road is essential. So as the density and risk increases, so does the structure and control. So we have a lot of new players to the industry, a lot without domain expertise, and from an industry perspective, a lot of that is great. It forces us to do better. It forces us to be innovative. It forces us to get out of the malaise of air traffic management and accept new technologies, new approaches, new ways to solve problems. But with that comes a responsibility from aviation stakeholders to come up with a new structure, a new regulatory policy, and a performance-based set of requirements by which we can operate within. We need to have rules of the road both for the air traffic system as well as for those vehicles that operate within the system. So this is an interesting slide that we put together. So we took the FAA's terminal airspace forecast, and over the next several years, we estimated the size of that terminal airspace, how they may continue to grow. We estimated that to be about 100 cubic nautical miles, and placed manned and unmanned systems in that particular airspace. There was a drone delivery paper that was written recently that we extracted some information from Dr. Tulinda Larson, and we took the U.S. government GDP data for the top 10 metropolitan areas within the United States and mapped on their drone deliveries versus the increased demand aviation. What does that picture actually look like? So Sean had alluded to some of this before. All these operations will be under 400 feet. These are on approach to airports, and these are drone operations. So as you can see from the picture, we need to think about this much differently. We're going to have an impact between unmanned system and manned systems very quickly. And how do we solve this problem? So a little bit different view, but I think a lot of the underlying concepts are the same when it comes to our view of how we tackle low-level airspace management. So Thales sort of breaks this down into a couple of different components. The first side, on the left side, we show low-altitude airspace management. So these are the safety-critical functions. And in NASA and FAA vernacular, this could potentially be the FIMS system. Internationally, we're being sought out by our customers to come up with an airspace integration plan and figure out how to put unmanned systems and personal air vehicles in the same airspace as manned aviation. So for us, we continue to maintain our safety-critical focus. We're not a USS operator. We're not a package delivery company. We don't do those the applications that require drone integration into the airspace system. What we are is a safety-critical air traffic management company in this environment. On the other side are the operator services. So these are the USS suppliers. As Sean was showing before, I think there needs to be some level of integration and interaction between the various USSs, but our view is slightly different. Do we need to have integration and interaction between the USSs, or do they go through a layer where deconfliction, airspace planning, safety critical elements are then applied to those missions? And given the fact that this is a safety critical environment, how do you give priority to emergency operators, other operators that may be in the system, the military as an example, that need instant access to the system? How do you get in touch with each of the operators that are out there? The biggest challenge I think we're facing from an industry perspective is the introduction of all these external users to UTM and to low-level airspace management. We have to now come up with solutions that maintain the airspace structure as it exists today, but also accommodates the growth and the future technologies that we need to embrace as an industry to move this forward and do it in a safe, efficient manner. Cybersecurity, big data analytics, artificial intelligence, all things that we are planning for in our systems as we deploy these in the future need to be considered as part of the overall solution as we start to look and see how these things will grow. As we look at common technologies, commercial technologies that are out there, that really helps us then look at harmonization globally. So if we can consolidate, come up with some ideas around data exchange models, how the UTM portion, the UTM core portion versus USS operators come together to plan airspace and deconflict, standards will emerge. We'll be able to figure out how to do safe, efficient data exchange models and also maintain the safety of the overall system. So this is our view. It's a view. We'll have many more views of this to come, I'm sure. But thank you very much for that, and appreciate your attention. Thank you.
Thank you, Frank. And interesting, I picked up listening to Sean's presentation and Frank's presentation. They both had key focus areas on future traffic density and also both relating to the importance of safety. And Frank, you started to talk there about new ways of solving problems within the established airspace structure, and you then went a step further on risk management and risk assessment. So I'm going to come back to both of you with respect to safe operations, considering the planned future density of operations. So I'd now like to introduce our next speaker, and it's James Burgess from Google X. And James is the co-lead for Project Wing. And he leads the team that coordinates business strategy, product capabilities, and system integration. He's been with Project Wing since 2012 and is an inventor on a number of Project Wing patents. Prior to his time at Project Wing, James innovated in robotics and energy startup companies, including living in India for a few years, bringing renewable energy to off-the-grid villages. James lives for aviation, beginning as a kid was a remote control aircraft and then becoming a paragliding flight instructor and private pilot and aircraft owner. So please, everybody, welcome James.
Good morning, everyone. It's a pleasure to be here. I'll start briefly with the history of our project so you have some context, and then get into the exciting stuff about what we're doing today and where we're going in the future. So we started Project Wing a little over 5 years ago with the inspiration that every time we remove friction from how we transport goods, things improve. Economies can grow, new businesses can form, quality of life gets better. And we view UAS as the next logical step to reduce that friction further. And not just first-order effects like lower costs and faster speed delivery, but also second-order effects like removing traffic congestion, making it more environmentally friendly to move things around, and even improving people's quality of life due to their access to goods. So we started in Australia in 2014 with our first public demonstration of delivery, and it was mainly a test for ourselves. We wanted to put our technology to the test and say, is this a crazy idea or is there merit here? And we delivered some items to a farmer in their field in rural Queensland, and we came back actually feeling quite good that there was promise. So we looked at how are we going to make this a business? How are we going to make this scale? So this is a cartoon version of our ConOps, but first and foremost, we're user-centered. It starts on the left with the user saying, I want something, I need something. And that's a little bit atypical to aviation, where it typically starts with the pilot. I need to fly something. I need to go somewhere. And once the user enters into the system and places an order, our system coordinates an aircraft to launch from our nest, as we call it, flies to a merchant, picks up a package to enable small businesses and others to send their items, flies the item to the user, drops it off, and then comes back, all in a fully automated way so it can recharge and be ready for the next mission. After looking at this for a little while, we realized if we were even going to be remotely successful at this, we were going to have more aircraft than we knew what to do with. And we needed a way to manage them in an automated way, not using manual processes. So a full second half of our project was born, and we started working on UTM systems in 2015 to manage the integration of aircraft into the airspace, and even do the additional things that were spoken about, like fleet management and configuration control, so we could manage a large fleet of aircraft without manual input. In late 2016, we partnered with Virginia Tech and Chipotle. Maybe some of you saw the YouTube videos, and we did burrito delivery. Yes, it's the burrito drone. But for 3 weeks, we offered delivery service to paying customers, and we delivered lunch to them. We delivered just over 1,000 burritos to students and faculty, and it was a fantastic experience. We learned a lot. But one thing you can't tell from this video is people were coming to us. We set up the operation, we even put some safety nets, and we said, come on, give drone delivery a try. It wasn't really the promise of convenience. So we thought about what are going to be the next steps that allow us to bring the technology to you, into your environment. So we needed to do more testing and development. Most of the last year has been spent internally testing in our California facilities. We've put over 30,000 flights on our configuration, and in the process earned waivers to the FAA Part 107 rule so we can fly at night, fly one-to-many aircraft, that's one pilot controlling up to 20 aircraft in our case, and ops over people based on reliability, not just kinetic energy making it inherently not dangerous, but saying we have a justification based on the failure rates being low enough it's safe to fly over people. And we also set a goal for ourselves to improve our reliability and automation by 100x, 2 orders of magnitude. And one quick side point on that, reliability and automation, we learned, are not really different. They're two sides of the same coin. So a quick tangent into some of our experiences. I wasn't able to share the real data with you due to legal reasons and things, but this is the sort of qualitative view of what we experienced. As we iterated on our automated systems, we saw the failure rate come down, and as we improved our training and processes on the manual efforts, we saw the failure rate come down a little bit. But in April of this year, we experienced a crossover, where we actually had more failures due to human input, whether real-time or configuration management and other things, than our automation and the way we do that in an automated way. And so that gives us the motivation to push everything we can into the automated layers. And one quick example of that, we at the time had safety pilots with RC controllers, and we found that actually by removing those from the system, it got safer. Our data bears that out. And that was a pretty non-intuitive outcome. I'm a GA pilot myself, and it's hard to admit that yes, humans make mistakes. But if you develop the systems well, automation can really go a long way in solving the problems. So an example of that, here's our system flying. We're purposely doing fault injection. We're taking the control surfaces, moving them to hard over positions as if they failed in the worst case, and then seeing how the system reacts. And we build in contingency management and failure handling systems so that the aircraft can keep flying safely and either finish the mission or abort and land safely, at least not causing any hazards. In parallel to our delivery operations, we began working on UTM systems, as mentioned, and a big thanks to PK and his team. We participated in the TCL2 event earlier this year in the summer, and we were at Virginia Tech testing our UTM system with our own delivery vehicles, as well as Intel Aero drones and DJI aircraft. So just a couple still frames, and then I'll show you the animation coming up. This is a BVLOS, beyond line of sight flight of a DJI drone that's using our UTM system to plan its flight to do the search and rescue, as well as deconflict from terrain. So you can see through the reservation volumes there, it steps up as the terrain rises, even more so over the trees on the top side. And in parallel, this was an Intel Aero drone doing a search and rescue mission while a wing delivery vehicle flew over top to do a delivery. We were testing the system's ability to deconflict between routes, between operators. And we could say, yes, we can input manual deconfliction on heights or altitudes, but what if we just trust the software and let it perform the best route planning available, ensuring that no conflicts happen? So here it is, sped up from real time. We have the wing aircraft in the middle performing delivery missions to those packages while search and rescue flights go on. We even simulated a TFR in that red zone, so some of the flights were planned around that to do integration into airspace. And you see people started getting bored and testing the system flying logo flights with Intel and the Project Wing and Google logos. And it was really great to see this process throughout the day where we started quite deliberate, setting flights at different altitudes, and by the end of the day we said, hey, the software works, let's just trust it. Put flights in the air, the software will deconflict, challenge it, fly an Intel logo and see how that looks. And it was really, really encouraging for ourselves and others to see how the progression of trust occurred just throughout 8 hours of flying. We challenged the system next and we said, what about the density of airspace? You saw some of the projections earlier. Can a system like this actually handle that? So we orchestrated kind of a contrived scenario. This is our facility in California where we work. It's about 200 meters from left to right. And we crammed as many delivery flights as we could, taking off from the left, picking up packages in the courtyard, delivering to the right, and vice versa in the other order. And we found we could fit about 18 aircraft simultaneously delivering because we're deconflicting not just in 3 space, but in 4 space with time as well. So the reservations are just used for a brief moment as the aircraft passes through. And you see that these software solutions can really scale to densities that are probably even unreasonable. I don't know anyone that needs 18 deliveries to one parking garage at one time. Well, we progressed, and earlier this year in July, we started delivery operations in Australia. We're operating in some rural neighborhoods outside of Canberra. Since July, we've been doing this, and we've worked up from line of sight to beyond line of sight flights, and we're flying over people, even though the densities are relatively low. We've done about 1,000 flights so far to date. Half of those have been commercial orders, half testing, and these are all on-demand routes using our UTM system to plan the flights, deconflict, and so on. So I'll dive deep onto just one example to show you how that works in practice. Here's an aircraft flying through its reservations. Those white boxes are the 4-space reservations. And it flies to the customer's house up and over the hill, delivers a package, and then returns. And as it's operating, notice those little blue icons. Those are actual real-time telemetry sent by the aircraft to the UTM system to inform the pilot of where the aircraft is, but also the UTM system monitors the flight to see if it's conforming to its volumes. So see here, it turns red. Those alerts are given to the pilot in real time because the UTM system is monitoring, saying, hey, aircraft, you're not staying inside the volume you were supposed to. And so this capability allows us to do what has been mentioned before, which is take a manage by exception approach. And one of the ways we feel comfortable having one pilot operate 20 aircraft is because the UTM system flags to the pilot, pay attention to me, I need help. Otherwise, everything is automated and goes about its business. We picked this example because it happens to show an error. We had an altitude offset error, so the aircraft was flying 2 or 3 meters higher than it should have been. In addition to helping aircraft fly more effective and more automated where they are allowed today, we're also looking at how UTM can provide access to places where aircraft are not currently allowed, unmanned aircraft. And so we're working with the FAA under the LANCE effort, Low Altitude Authorization and Notification Capability. We're one of a few providers that are offering this service where we can sort of automate and approve UAS access to controlled airspace by using a pre-approved map from the FAA and from the airport authorities. So in this case, the altitude is reflected by the color of those squares. On the left is San Jose and Reed Hillview airports in the Bay Area. And you can see that a UAS would typically have to stay outside of those controlled airspace zones, but by using the LANCE effort, we can pre-approve them on the UTM system to fly into controlled airspace as long as they stay under that predetermined altitude. On the right, since we're doing work in Canberra, is a sort of hypothetical example of what that would look like for a busier airport. There's 2 runways with different approach and departure paths, and you can see how the altitude is restricted as you get closer to those flight paths. This allows highly automated operations and access of UAS operators into controlled airspace without having to bother the ANSP or the airport controlling authority with requests that sometimes take 60 or 80 days and a lot of paperwork. In this case, it takes just a few seconds. Another thing is we're integrating UAS not just into airspace, but also into people's lives, general public, local authorities, and one thing that we're keenly aware of and sensitive to is the balance of transparency and privacy. So on the left you see there's a lot of need for information. The public or local authorities want to know what's flying, what's around me, but on the right side, there's some sensitive information, whether it be from the operator or manufacturers. And just as an example, if I order a delivery from a pharmacy, I might not want my neighbors to see medicine flying from the pharmacy to my backyard. So what's the right balance? We're not going to take a position in detail today, but this issue is really important to us. And in the center, you see an example of a remote ID solution we're working on, a sort of map that shows aircraft flying around that balances privacy and transparency. So what's next for us? We're going to be expanding our delivery service. We're always interested to hear from partners or other countries that might be interested in having us. We're launching UTM as a service in the future. We're committed to providing a basic layer of UTM service for free to all third-party operators. We want to demonstrate our remote ID solutions with local authorities and the general public and see what is that right balance of information and privacy, and continue collaborating as an industry. We have to find ways to make things safe and interoperable together. One specific solution is not going to be the right answer. It's going to be a collaboration. So final slide here is just what's needed for the industry to excel and to move forward. First and foremost is more data. There's a lot of conversations that happen with a lot of speculation or assumptions, and we find that if we can just go out and do a test or do a demonstration, that experience yields so much information and much more insight into how the future should take shape. We like to see more risk-based approaches rather than strict legislation or regulations that conform to one solution. If you look at the risk and can quantify it, you should be able to approve operations on that basis. We'd like to see regulations take a pro-innovation approach. As Florian said in the previous session, as you heard earlier in this one, we have software solutions to these problems. We need regulations that work with that level of innovation and development. And if it can be easily accessible so our systems can grab those regulations and put them in the UTM system without a lot of manual input, it will be faster and more scalable. And then finally, balance all stakeholder input. We see a lot of focus on the ANSPs and the airspace, which is good, for safety especially, but we also need to balance the input from the general public, from the bystanders, people worried about noise or other issues, as well as the operators themselves who have sensitive data and need to be out there operating. So that's it for me. We look forward to your questions. Thanks so much for the time.
Thank you, James. I'm sure there'll be a lot of people interested in the free UTM service that X or Google X is going to provide, so maybe I'll ask you to explain a little bit more about that later. But also, you started the presentation about reduction in friction for society and then demonstrating how the human being removed from the loop could actually increase safety, and then you ended on your penultimate slide about risk as well and a risk-based approach. So the safety theme again, which we'll focus on. So I'm going to introduce our last panel member for this morning, and the last panel member is Dr. Kin Hoot Lau, who is a professor in the School of Mechanical and Aerospace Engineering at the Nanyang Technological University in Singapore. He obtained his bachelor's degree from the National Cheng Kung University in Taiwan and his master's and PhD degrees in mechanical engineering from the University of Waterloo here in Canada. King Hoot is the principal investigator of Traffic Management UAS program, which is concerned with UAS traffic management and concepts of urban drone operations. And he is an honorary member of GUTMA, which is a global UTM traffic association. Please welcome Mr. King Hoot Lau.
Good morning, everybody. I'm very honored to be here together with the panel member to share my UTM work to you. When I first received an email in mid-October from Leslie about this invitation, I'm very excited. I'm even more excited in the next Friday, receive second email talking about in my panel, you will have PK. Wow, PK from NASA. You have Amazon, Google, and Thales. I'm even more excited. Luckily, I did not receive the third email, otherwise I would get heart attack. Yeah, so today I'd like to talk about the work we have done for about a year for this UTM. I must thank to PK. We inspired for the PK visit on this UTM. Even we have submitted our proposal, but after that, with ETA, with PK advice, we actually know more about UTM. So my team always says something, give me an equation, UTM equal PK. Yeah. So today I will talk about urban traffic management of unmanned aircraft system. I put a small U instead of bigger U, UTM, urban UTM, this small U. That one is for Singapore. I will tell you why we talk about that. And you can have an example for the application for the unmanned drones, unmanned aircraft system. There's so many applications just now the panel member talking about. And you can have beauty. This is a beauty place for some of you who have been in Singapore. It's beautiful. It's urban. Talk about future. Future, you talk about a number of drones operate in the same time period over a managed airspace. So this is something to talk about application. Why UTM? Because you can talk about everybody this morning, yesterday, the growing demand of benefit. You must have benefit. I have been in robotics for 35 years. Recently, robotics come out because the benefit, so commercial benefit, a lot of industry company join in, so you make the thing grow. So this benefit of UAVs or drone operation seen by agency, industry, and commercial usage. And also to optimize and maximize this commercial benefit in future. We are not talking about one drone, we talk about many drones expect to do different job over the same sky. So in this case, traffic management is really necessary to ensure the safe, secure, and efficient drone operation. Just like how road traffic manage the movement of cars, buses, and trucks. If you only have one car in United States, you don't need highway, you don't need traffic light. So because of many traffic management is there. And today we're talking about, especially for Singapore, later I will show you why, we talk about low altitude. Yesterday we have a talk about high, but now we talk about low altitude and unmanned aircraft system. This is something rapidly developing concept. This morning actually some member mentioned about even free or charge for that. It's a rapidly developing concept and platform that industry is hoping to implement sooner than later. Why urban UAS or traffic management? When you talk about urban, you have all this in mind, very high commercial activity, and come to Singapore. I always mention, email and chat talk about urbanization defined by United Nations. We score 100%. Singapore, we score 100%, and it's a densely populated urban environment. And another thing is, as soon as the safety and the security ensure, the number of drone operation and activity in urban town are expected to be several times of more than those in rural areas. So when you talk about urban traffic management, there is more than many reasons we need to do a good job and traffic management come in. So we like to talk about basically just make use of Singapore, talk about signature of urban infrastructure. When we do this UTM, our team actually come together, we actually have a certain principle, certain guideline. We like to zoom various urban town in small area. This is meant for efficient and effective management of a drone operation because different town, different area, they may have different requirement. And we also like to make good use of existing urban infrastructure, mobile network, and facility. Because you just don't build something extra, addition, just to support this so-called industry drone operation. So we're talking about in Singapore, you have been there, many shopping area, retail area. We're talking about resident area, we talk about apartment, we talk about open area, we talk about multi-story car park. So we need to make use of all this to have a designated discipline point. So that is something, some guideline we based on our study. So this is something that I presented. Thanks ICAO for the invitation. We come out the first framework, modular framework. When I say modular, we can have this framework there, different country, different area can apply to add, to remove some of the item. But basically you need to have UA operator, you have UTM operator. In some country, you can talk about many service provider, but in some country, maybe one is enough. That depends on the situation. And we also have user interfaces. We have a UTM, UAS. Under UTM, UAM function, we actually have urban management. We talking about flight management and risk management. So I just want to show you the video. Should I just press it? Oh, I cannot. Yeah, just too fast. So why don't we play this video? Because I know I run out of time. That's a problem for professor. So this is something that we work with AGI, Nova system, and basically you just put everything in a so-called concept to see how it works. And then we're talking about multiple drones. You can have one company key in so many different drones, and then to actually ask for from point A to point B. And you can see they will have all this UTM inside, and to find out perform the routes analysis and the editing. And you will show that the thing can work. They will have so-called GPS signal, how is the signal and terrain. Maybe I should jump to the next slide to save time. Yeah. So recently we have a statement, we have a collaboration output talking about the communication C2 link, which is very important. And this is actually the slide to show that we can match the network coverage in a certain area, and then we can actually transfer this network mapping to our software, and our software can come out with the road, possible road. And then we come to the 1 week later, we will be able to fly the real demonstration in front of the M1 building. M1 is one of the telco company we work together. So by having this communication link, especially for Singapore, it's a limited airspace, we can actually maximize and optimize the airspace. Most important, this so-called communication link will be very relevant to DAA and geofencing study. So the next thing we're going to do is capacity. I should not spend too much time here, but talking about the urban UTM purposes, you have to talk about capacity. You want to see many UAV can work at a period of time, provided the safety and security, all this will be ensured. So we have all this study based on the car industry, how many cars you allow on the road. So the risk management is also important. This is important because it's only that you have this, the insurance company will cover the insurance of the drone operation. Just now people talk about privacy, all this, and so this is something that the team will look into it. So the challenge of opportunity. Maybe I just quickly mention that even expected the drone operation in urban environment will present greater operation challenge with high risk to the people and property. However, we should not underestimate or ignore the drone technology potential and application to economy benefit. So what we need, we actually, beyond we are from the research institute, we talk about university, we require a collaborative work with many different stakeholders. And our research team in NTU have been working closely with various partners and in different capacity to actually explore possible solution to co-develop concept and enabling the technology for field tests in very, very near future. So thank you for your attention, and all the credit go to the team, the project team, and also the student. Thank you.
Kin Hut, thank you very much. And one of the novel situation you're in, that any testing or research you're doing with operations in Singapore is by default in a dense environment and the city urban infrastructure. So I've actually got quite a few questions on the iPad here, which is great, and so I'll give those the priority for the panel, and I'm going to just use some of the explanations that came from the panel to ensure we've got a bit of a segue between the question and actually what was presented. So Frank, I'm going to ask a question to you first, and you gave the overview of your work and Thales being a safety critical ATM company. So with the advancements in technology and the application of rules and regulations into the airspace, do you think some of the concepts of operation that are being developed or considered for UAS operations, especially considering the future density of operations, will they be transferable into traditional ATM?
Short answer is, I think yes. And I had a conversation with a gentleman to my left about a year ago, maybe it was earlier this year. We talked about UTM-enabled ATM. I think as we see more dense operations and unmanned systems and remotely piloted systems and general aviation all getting crammed into lower-level airspace, I think that a lot of the work that's being done is certainly transferable. Again, it's technology at the end of the day is not going to be the largest hurdle out there. It's going to be regulatory policy, setting up rules of the road, the game plan that we all have to work within. But certainly some of the good work that's being done by NASA and other ANSPs and regulators worldwide will certainly be transferable.
And thank you, Frank. You mentioned NASA at the end there. And PK, part of your responsibilities in NASA, you've obviously got UTM, and you've taken that from somewhat of a blank sheet of paper. You've got an air traffic management responsibility in NASA's work and your work. So the question is, do you see the transferable concepts of operations? We talked about air traffic management, but what about manned aviation, commercial manned aviation? Are we going to see a transfer there and evolve the way we actually operate aircraft?
The short answer again is yes, but I think we are still on the UTM land and very much on the research phase. And if the UTM is successful, what it opens up is cooperative traffic management. It opens up service-oriented architecture, ability to leverage services from industry. So many of these tenets that and also managed by exception. So if the UTM experiment is successful at the low altitude, at the high altitude, in the space, and then for urban air mobility, then we start to look at picture that will leverage these things, as I mentioned. So I think there is a great promise. Clearly, as a researcher, I should not be salesman. So we need to make sure that we have complete data and results of the success of the UTM, and then we take it from there. But I think there's a good promise. I mean, this is the exciting part of our research.
Yeah, I think people agree there is great promise, great potential. Just ensuring that we have interoperable, capable and secure systems. Sean, you very much had a focus in your presentation around using the available established infrastructure and systems. And the question that came from the audience was, what about internet security?
Well, as you might imagine, I work for a company that takes privacy and information security very, very seriously. There's a lot of industries that are currently in action right now, financial, telecom and whatnot, that are working very well towards developing protocols that ensure that the systems continue to be safe. Relating to a UTM kind of construct, one of the things that we think has to happen in terms of having an interoperability piece, especially in more complex airspace, is the ability to validate that somebody who says what they are, they really are, which is not unlike the types of identification and validation protocols that already happen in the internet-based industry and telecom.
Thank you, Sean. Again, questions from the audience and a focus on USS, Unmanned Aircraft Systems Service Supplier, and that's been mentioned a couple of times. How do we ensure there's an appropriate oversight and fair competition of USS suppliers for the future? I'm going to start with PK because you put this in your concept of operations, and then I'm going to ask Sean and James. And actually on on James's point, I'm going to ask about your free service. So PK first, how do we...
USS construct is really about leveraging, again, industry's capabilities. So if you look at why we need USS construct and where it can be useful, you could have a complete set of services provided through the USS, or you could, so that include flight planning, tracking, separation management, and whole bit. Or you could have selected services such as only tracking, only communication, navigation, and such. And when we opened this space and we said these are the requirements for you to interoperate among each other through the data exchange protocols that we set up and application protocol interfaces that say this is how you will connect with the ANE, ANSP, and FAA in the case of US, and this is how you will interact with each other for sharing intent and any alerts and any off-nominal conditions. If the industry members follow those and they can basically connect and show that they can demonstrate that they can follow these principles and guidelines that we set up, then I think it opens up the competition, and it won't be a monolith. At least the view is that it is not a monolithic one service supplier network. I think the more competition and the more services we have, the better it is. Also, some cases the USS provide vertical integration to the businesses. So without taking any names, but some people want to use their cloud services or data services and the whole bit. So they have fully integrated USS into their other business aspects. So that again allows them to basically leverage the commercialization of the data and other things that they collect through the drones. So I think USS offer that opportunity, and we look, I think, forward for a day where you have multiple service suppliers.
So generating competition, not one service supplier, and commercialization. Sean, your view on that, and do you want to control your own aircraft?
So let me answer the last question first. In the model that we demonstrated in my presentation, in that instance, we would be managing the movement of our own aircraft, and we would be interacting with air nav service providers, aviation authorities, and other operators who would happen to be occupying the same space of airspace as us. And I think that last part is the important part, is that having a model in which you establish areas of operations and intent and you kind of limit that communication interchange allows you to scale indefinitely. And basically all you then have to do is kind of design or define the size of the polygon, the area of operations that you want to be interacting with others. Going back to your first question, let me give you a little bit of an answer from my past. So if an airline, if an aspirant wants to go in operations, they have to go get an operating certificate. They have to demonstrate that they can make an economic use case, and then they also have to demonstrate that they meet minimum safety bars. The aviation authorities don't say you can or you cannot go into business because there's too many folks that have operating certificates. They just kind of defined what the standardized protocols and what the threshold things that you have to do to operate. It's no different with USS. And the last part that PK left off, I think, was very salient. The whole concept of a USS, a service supplier, is not a monolithic answer. You could have very austere, very limited USSs, which maybe provide one little data point. Perhaps a weather information service provider or somebody doing data analytics. Or you might have somebody who is a little bit more complex operation that's, providing those services in-house as well as managing the movement of their own fleet. I think the important part is that we have those protocols very clearly defined, and we ensure that that interoperability piece is taken care of as a threshold value in order to conduct operations.
Thank you, Sean. And James, I'd welcome any comment on the USS topic, and maybe give us a little bit more information about how the Google free UTM system, how you envisage that will be working.
Thanks, Rob. Okay, there we go. First of all, just to talk about philosophies, we think competition is a great thing. We're really excited to be pushed and challenged by a lot of stakeholders and participants in this realm. We think that helps us to advance, to innovate, and to keep pace not just with the needs of operators in the market, but also take advantage of technologies and innovations as they come. So we really want to see an architecture and a method going forward for UTM that inspires competition. That said, I don't want to stretch analogies too much, but if you look at the early days of the web before HTTP standards were developed, there were a lot of sort of one-off solutions, a lot of connectors being built one at a time to try to get the system off the ground. And I think that's the phase we're in now, where we're trying to figure out what is the best format and structure for having UTMs share data and deconfliction information with others. And that's one of the things that pushes us to think about how are we going to get adoption of these systems. One of the key features of UTM is it can deconflict aircraft from any other aircraft using a UTM system. So how do we help encourage that participation? On one extreme, you can legislate it or require it. On the other extreme, you can incentivize it. And we're looking at that model saying, let's reduce all the barriers we can to get people onto a UTM system so that all operations can be deconflicted and managed safely. So at least some basic layer of UTM service we think should be free, and we, I'm sure, will not be the only ones providing such a service. And that opens the door to get more people on the system, more operators on the system, and then allow further advancement and development and even commercialization or monetization on higher level services. So we're excited about competition, we're excited about interoperability with other participants, and we think this won't even get off the ground if we don't have sort of universal access and the ability for all players to operate in a federated open way.
Thank you, James. Kim Hood, so we're talking about USS service delivery. We've talked about density of traffic. I mentioned after your presentation about the somewhat novel situation that Singapore as a state is in with the density of traffic. What's the main challenges you've encountered or you have identified for more of the urban air mobility, the operations around cities? Please walk us through those challenges.
I personally feel that the challenges in Singapore, talking about UTM study, you talk about DAA, you talk about geofencing, it's the same thing you apply to other areas. That is a technology, that is a research that many countries, many universities would do. But for Singapore, if you look at, just now I mentioned about the map, the population, I think there are two constraints we're talking about. First is a space constraint. You talk about US you have 6 test sites. And in Singapore, we want to find one test site for people to do all this research and application or testing is quite difficult. Not easy because of situation in the country. But I was told that actually the government already have innovative all this good method to solve the problem. They will soon identify area that can do this. Another constraint we have is time constraint. And just now I was so jealous that PK mentioned about how many people working on this NASA UTM, and Japan is talking about how many company. And in Singapore, because of a small country, limited resources, we actually just a handful of people working on it. That's why working with industry, Singapore is always keen to work with the best of in the world. So we actually have a partnership with local company, international company, and in different areas. That's why I want to thank ICAO. This ICAO is a good platform for me, for many of us to be able to work together. And for example, the drone enable, and today the Cannes symposium, and talk about future. Chris talk about the ATM meet UTM. That could be another good platform to solve all the problems. So I really want to make use of all this platform to actually solve this second constraint, which is time constraint. So I don't mind to be invited again. Thank you.
If you can just deselect your mic. Thanks. We've heard about USS, service provision, competition in somewhat of an open market. Let's call it Class G airspace. Frank, I know you're representing Thales and you're an OEM, but do you think ANSPs, maybe on the technical level, on the conceptual level, are going to be happy that they're going to have independent or third-party providers in providing a service in their airspace? Is it going to be a harmonious relationship, or will some ANSPs want to provide that UTM service themselves?
I think that's why we draw the distinction between USSs and a UTM core functionality. So, I like the view that miraculously the USS suppliers are going to exchange data and sort out each other's missions and try and figure that out. We can't do that with airlines today and schedule swapping, so I don't know how this is going to work. But so when we look at, from our perspective, I think the ANSPs are going to face an enormous challenge. One is the affordability of this. You're going to have to come up with new models to figure out how to pay for the infrastructure to support the integration of unmanned systems in a low-level airspace. I think the other piece is it's literally a food fight today to try and figure out who is going to be out ahead, who's going to put their system in place first, and then does that necessarily drive regulation and standards for our industry? And from the Thales perspective, from the air traffic management perspective, we need to continue the global dialogue on the right way to do that. But we've laid out a plan, and we're committed to that one piece. We can see that there's going to be multiple operators. There has to be for various commercial applications, whether it's public safety, whether it's package delivery, whether it's insurance for insurance claims, taking photography, whatever the case may be. But to have all those disparate commercial interests try and sort it out, I think that's going to create some big issues. So no, I don't think they'll be happy.
Interesting times ahead. PK, question for you, and I'm paraphrasing from an audience question. Just explain to me, we're talking about low altitude, we're talking about cities. Explain to me about the stakeholder consultation and involvement of entities who are most probably not familiar with aviation, town planners, authorities, police forces, etc. What's the engagement, and how are we going to move forward with a new area of aviation that's going to touch an awful lot of non-aviation related government and local community responsibilities?
Very recently, President announced integrated pilot project, and Department of Transportation is taking that pilot project as a means to understand the needs of the local, regional and federal jurisdictions and operations. So that legislation, or that basically whole initiative, is going to give us a lot of insight into the roles of the localities that might play into this. So that's happening at the policy level. On the technical level, we have been having number of workshops and dialogues with public safety institutions such as firefighters associations and the local firefighters and few other police force and such, to figure out what their needs are and how we integrate that. In fact, we're going to have a workshop, I think, end of January, to just talk about how the UTM helps the public safety type of services. So it's happening at multiple levels. And in one of our concepts, you probably saw the principle that public safety drone will always have priority access over everything. So if that happens, what that means is in the concept of UTM, we need to be able to send alerts to the operators that are using the airspace at that time and say, hey, we have a search and rescue priority, please clear the airspace, and then that operation will take place after that. So we have already institutionalized in the system these sort of alerts and requirements to be able to give access and priorities to certain class of users. Now, that's not NASA's decision who has a priority, obviously. That's up to the FAA and the policymakers to decide that. But nonetheless, we have taken into account how that will evolve. So, in summary, there is basically already work that's initiated at the Department of Transportation and FAA and President's level about the role of localities into this, and then from the technical level that we basically have already features and capabilities inside the UTM construct that will allow you to do that.
Thank you, PK. All of you are actively involved in operational trials or testing, and we have, as an aviation industry, safety is our number one priority. And also, throughout the presentations, there was a common focus on risk assessment, mitigation, and safety. So on your own experiences with your organizations, your companies, do you consider that the current industry guidelines or models we have for safety assessment and risk assessment, are they adequate, or are we going to have to look at safety and risk assessment differently for UAS, especially considering there may be an exponential increase in operations? And I'm going to start with you, Sean, on that.
So I think as a starting point, the safety assessments are adequate, but they are going to definitely have to adapt for the future. And let me give you an example. Over in Europe, you have the aviation package that went through the notice of proposed amendment cycle, and part of that is the creation of something called a specific operational risk assessment, which looks at the vehicle and it looks at the concept of operations of the business case, and then it basically it creates an operating certificate based upon the specific attributes and risk factors and mitigations in that business model. Now, that to me makes a lot more sense than just doing a cookie-cutter safety risk assessment that would apply to manned aviation. And so I think that there's certainly movement in a very positive direction. The same thing's happening in the United States with the creation of operating rules, which defined, kind of put brackets in the type of operations you could do. But if you wanted to do other extended operations through waiver, nighttime operations, multi-vehicle operations, beyond line of sight, operations off a moving vehicle, it would require a specific risk assessment and demonstration of how are you going to mitigate to those risks. So I think that we're definitely moving in the right direction, and I think that the focus, not just on meeting kind of prescribed, kind of somewhat legacy safety bars, but really indexing it to the risk of the actual operation is certainly the way to move forward.
Thanks, Sean. James, would you like to make a point?
Yeah, thank you. First, I just want to emphasize what Sean said. We agree completely that we're moving in the right direction, but adaptation is needed looking towards the future. We heard about in the first session the work JARIS is doing on the SORA process, as you were talking about, Sean. We think that's a fantastic sort of step forward in the right direction to look at risk on a case-by-case basis. One of the things, too, is I know UTM can mean a lot of things to a lot of people, but there are technology solutions available to us now that weren't in the manned aviation community before. So, for example, as I mentioned in my presentation, we've done tens of thousands of flights, and that's really quite achievable to do, to get those quantities. And so you can quantify reliability and failure rates and risk in ways with UAS that you can't do in manned aviation. And further, just to really take that idea to the extreme, we have our UTM system monitoring the flights to see if aircraft are staying inside their volumes. That's sort of like the base layer number one. But you can go a step further if operators are willing to share data on the batteries, the motors, the flight performance, technical capabilities, and so on. The UTM system can even monitor and even predict safety issues before they start. Maybe navigation becomes poor in gusty winds, and the UTM system can alert based on those scenarios. And so I think there's an element of managing risk that can even be brought into the real-time operations and allow easier access for operators and aircraft manufacturers on the UAS side to operate safely. So we're really excited about that potential. We don't want to propose any specific answers here, but I think the future looks bright for risk mitigation.
Sean, you'd like to make another point?
Maybe, there we go. One other thing to point out, and actually this is like the very apropos for this crowd, Annex 19, when the SMS annex, the newest annex was passed at ICAO, I think that was very useful because that is a safety management system that's actually indexed to the specific attributes of the operation. And guess what? At Amazon, at Parimal, we have an SMS system. We have a data collection system. We have analytics. We do cause of error analysis, and we track everything to completion. And so I think that, that to give credit where credit was due, I mean, it gives us a great operating framework that kind of traces our approach back to legacy aviation, but is very adaptive to the innovations and the way that we approach data management and safety data in this emerging industry.
Thank you, Sean. So I'm going to start bringing the session to a close. We had some really interesting presentations from the panelists there on research, the innovation, the potential for the future, operations. We discussed in detail USS operations and to generate competition in a new marketplace. Urban operations was obviously a key focus, and also we identified the potential for transferable technology to air traffic management and manned aviation. And finally, most importantly, we're finishing on the safety side. So I'm just going to ask one final comment from each of the panelists on the discussion we've had today, and taking the opportunity to be in the ICAO headquarters here if they'd like to make any comment about future work of ICAO on UTM. And as per last time, let's start from the far end of the panel. Kim Hoot, any final comments from you today?
Yeah, as I say, I'm quite happy to be here. I believe that I also agree that personally we can learn a lot from manned aircraft, talking about safety and risk management. But two things different in my study is when you talk about manned aircraft, you have pilot on board. When you talk about unmanned, you don't have. Psychologically is different. When I take this Boeing 767 come to Montreal, if anything, please tighten your seatbelt, I'm okay. But if I'm in unmanned aircraft, I may not be feeling the same way. So it's something have to actually overcome, talking about that psychology effect. And also another thing is come to urban, a lot of things have to be carefully looked at. The safety, the privacy, security, and the noise. And this is something will be different if you talk about open area. So that's something that I feel that is very challenging in our urban UTM study, but also the challenging on the other hand, if you look at it positively, is opportunities. So what can I ask from ICAO? I want ICAO to organize this more often, so that ICAO is a very unique platform to put everybody together. Wonderful. Everybody together, different stakeholders to discuss about this. You can see for the last 6 months, last 1 year, I joined our past panel, but last 12 months, a lot of things happened talking about this small UAS. Thank you very much.
Thank you, Kim Hoot. James?
Yeah, thank you, Rob, and thank you for the opportunity to be here today. It's such an exciting time. There's so much we could mention and emphasize, but I think 2 points come to mind more than others. As talking about these risk assessments and basing operational approval on those, I think that's a really important point. One thing, just to put it in context, we shouldn't consider these operations in a vacuum. In our case, since I'll speak to that, we're delivering packages, and for every package that flies over a city and gets delivered, one less car is driven on the roads to do the same. And we can actually compare actual data from pedestrian risk and automotive risk on the ground and UAS risk in the air, and we can demonstrate that it's safer to fly packages through the air. And that's a case where inhibiting or restricting UAS operations is actually leaving society in a more risky state. So if we take that holistic approach and look at risk in that sense, it's not just coming from zero, it's coming from existing risk in the world today. So that's something to consider. And then second, I think that first point I made on my last slide, more data. We learned more from our first few flights to actual Australian households than we did in years of speculating about the problem. We thought people would be concerned about safety and privacy, but actually it was noise disturbing their alpacas and horses. And in that case, it's just one data point. But we learned so much from the real world. I would encourage us all to find ways to do pilot programs, do experiments. PK doing this for NASA on UTM, I think, is a great impetus there. We'd like to just see more evidence and more data that informs where we're headed.
Thank you, James. And Frank?
A couple of things. I think, again, we as an aviation industry really need to balance commercial aspirations versus the rich history we have as our industry. This is the safest transportation industry for a reason. We have over 100 years of experience building different platforms, trying different automation systems, legacy systems that have been in place for a number of years, and they were built to a certain standard. So I think as we start to see this industry really bubble up and start to become more prevalent, there's a lot of aspirations that impact our overall industry. I think we need to set some level of guidance for performance-based standards, a framework for a safety risk management assessment plan. SMS is a great way to get that started. We have to include cybersecurity into our solutions, and we have to focus on interoperability. I think the one thing above and beyond just those certain handful of things are segmenting the market in a way for the platforms that are flying so that they can get varying levels of service depending on capabilities. So certain platforms will have more capabilities than others. That'll help us to get to safety cases faster. I think we'll help convince our regulators a lot faster that these platforms are safer to fly and that there are different ways to perform different types of applications. So I think we need to be open-minded and not continue to stay in the same swim lanes that we've been in as aviation, but we also need to be cognizant of the fact that there is a rich history that we have as an industry, and keep that in mind as we continue to develop.
Thank you, Frank. Sean?
So I guess the high-level insight that I would provide would be to think in terms of incremental forward movement rather than what the end of the process looks like through PANs and SARPs and all those kind of things. Because this is such an emerging industry and because it's moving so fast, we need to have practical, safe demonstrations of the technology, the interoperability piece and everything else as you move towards more institutionalized solutions. I think if you look at the RPAS manual right now at ICAO and you look at some of the definitions, if you were to try to rewrite that right now, it would be quite a bit different, and I suspect, I'll end up on a provocative note, we would not be using the term RPAS anymore.
Thank you, Sean. And last but certainly not least, PK, please.
Yeah, I think I agree with everything people said here. This panel and the panel before, I would just say that the role of ICAO could also include this standardizing basically or identifying how the contingencies should be managed. For example, GPS degradation. We had noticed under flight testing that item that James pointed out. We have been doing lots of tests like all folks here, and we have noticed GPS degrades, and all of a sudden you can see only 3 satellites out of 12, and then your position accuracy goes down. So identifying these things and saying that these are the ways to handle that will go a long ways in assuring the basically safety of the operation. And last comment is go UTM.
And on that note, just a few administrative issues from my side. We're just about to break to lunch, but I'd like to remind everyone, as per the program, there's an air nav presentation concentrating on swim in the context of TBO, 1330 to 1350, and that presentation is being done by Eurocontrol, and that's in room CR3. Lunch is sponsored by IATA, and I'd also like to say a big thank you on behalf of ICAO to Kim Hook, James, Frank, Sean and PK, and ask the audience, thank you for your participation. Please give these gentlemen a big round of applause. And lunch is now served until 2 o'clock.